Welcome to the Exec Exchange, 15-minute podcast in which a leader from the water sector shares a story to inspire, inform, and educate other water sector leaders from around the globe. My name is Piers Clark, and my guest today is Dr. Bob Stear, Chief Engineer at Severn Trent Water here in the UK. Bob, brilliant to have you with us.
Nice to be here, Piers.
Now, let's do our usual and learn a bit about our interviewee. Tell me, what have you done over the last few decades to get to the role that you're in today?
I was born on the South Coast, went to university, did civil engineering. I thought civil engineering was a bit dull, but we went to a sewage works called Stoke Bardolph Sewage Works in Nottingham, and I saw what came in and I saw what went out, and I thought that's what I want to do. So I did a PhD in sewage treatment, joined Severn Trent as a sampler and then as a process scientist, and then gradually worked up through operational roles, starting off in sewage treatment and then went over to engineering, then to water treatment. A bit of time in government for a year on secondment. Then I came back to do innovation and now chief engineer, which is an asset management director by another name.
Brilliant. I love it. And I didn't realize that you'd done civil engineers and thought civil engineering was a bit boring. I actually did sciences and thought sciences was a bit boring. So did some civil engineering and ended up doing, just like you, a PhD in civil engineering and wastewater treatment. Now, I've known you for decades and I've only just learned that fact. Now, this is the first time Severn Trent's been on the Exec Exchange podcast, but you are actually a sponsor of this initiative. So tell us a bit about who are Severn Trent.
Severn Trent are the vertically integrated water company of the Midlands in the UK. We've got about 8.5 million customers. So on a day like today, which is pretty warm, we'll be doing about 2,200 megalitres a day of water into supply. We collect about 3 billion litres of wastewater. We do biosolids to agriculture, and then we've got a food waste business as well. So our core business is everything you might expect from reservoirs to land.
And for people who are not in the UK, what cities do you serve that they might recognise the name?
Birmingham is our big city. We've got Coventry, Leicester, Stoke-on-Trent, Derby, Nottingham, those sorts of ones.
Excellent. You're the only UK water company that doesn't have coastline, I believe.
It's true. We don't have a coastline, which is pretty relevant actually to some of the debate about things like what we were doing with our biosolids 70 years ago, because we couldn't put them out to sea like other folks were doing. So we've been doing things like anaerobic digestion.
Perfect segue, because the topic we're going to talk about today is circular economy, something I know is very close to your heart. And what I really want to get into is what works and what doesn't. It's always more interesting to hear about the things that didn't work, because that's the lessons we can all learn from. What does circular economy mean to Severn Trent? How broad is that topic?
So circular economy, for me personally, it started when we were just getting ready for the price review, what we would call PR14, which we're now in PR24, so 10 years ago. We did a bit of scenario planning work because we were looking at some of the threats that were coming specifically on the wastewater world. And we quickly came to the view that given the uncertainties around things like the biosolids to agriculture route, energy prices, population growth, climate change, we set out what we called our urban and rural strategy, roughly low carbon, low tech, nature-based solutions, types way of treating sewage in rural communities. Urban centres, we thought of them as biorefineries, and we were just getting going with that. So imagine a big picture on the wall with a conveyor belt, which was representing the sewage treatment process. And coming off that were lots of products with markets. And at the time, we didn't really know what those products were and what those markets were. And so for us, the circular economy bit was absolutely trying to get the absolute best value out of the 2.5 billion litres of wastewater a day that get given to us.
And some of those products were what? Things like phosphorus from fertilizer recovered from digesters? Is that the sort of thing we're talking about?
Yeah. And we went through the process chain. If you think about sewage treatment works, every product that leaves that site, every ingredient in that site, could you make that into a product? Because it's not so long ago that sewage treatment was viewed as a completely linear process and a one-use process. And at that time, as a sector, we were putting out about 20,000 tons of phosphorus out to the sea, so a finite resource and a fertilizer. Then that's something we recognized the better we could take phosphorus out and recover it, the better. So that obviously ends up in our biosolids, but also nitrogen, cellulose, heat energy, grit, screenings, the effluent itself.
Okay, so you rattled off 6 there, and I want us to touch each one of those. So let's start with heat.
Heat energy. So this is the one that I feel as a sector we've had a go at, but no one's really absolutely nailed it. The heat networks haven't been built over here. And so we've tried around with it and we've never quite got the heat one to work. And yet it's probably the one that's got the best value.
Okay, so now how about nutrients?
If I link it now with a net zero story, Back then, we didn't realize just how big a problem nitrous oxide was for the sector. The biggest emitter for us as a company in terms of greenhouse gas emissions is nitrous oxide. It's 273 times more potent than carbon dioxide. And you get nitrous oxide from the either incomplete nitrification or denitrification of sewage treatment. It's always been possible to remove ammonia chemically rather than biologically and reduce that risk. But just recently, the breakthroughs have happened. We think the right way to treat it now is actually to remove it as initially as ammonium sulfate, but in the future, ammonium hydroxide. So we've done a load of work with that recently. So I guess we come into that through the lens of greenhouse gas emissions, but it's obviously a circular solution rather than oxidizing the nitrogen.
So I said nutrients because that covers both ammonia and phosphorus and what you might do there. I wouldn't mind touching on the phosphorus as well, but let's just stick with nitrogen for the moment. So this is ripping out the ammonia and not just destroying it, which is what people have been doing, but actually recovering it so that you've got a product that you can do something useful with, either as a fertilizer or as a base chemical for hydrogen generation or whatever it might be.
Exactly that. Fundamentally, there are a few ways of doing it. Either you remove it chemically, or you find a way to turn it back into nitrogen and oxygen. So we've got this actilayer process that effectively we put on our big site at Stoke-on-Trent, which converts the nitrous oxide directly into nitrogen and oxygen gas, which is brilliant in terms of greenhouse gas emissions, but not so good in terms of product recovery. So that's still the kind of cornerstone of our greenhouse gas plan. And again, in the spirit of things that have worked and things that haven't quite worked, on our test plant at a town called Spurnall, we had a big anaerobic NBR plant, 500,000 litres a day pilot, which was seeking to do mainstream treatment of sewage with an anaerobic process, which again avoided the evolution of nitrous oxide.
Yes, because it's anaerobic. There's no aeration there for producing any of the N2O.
It didn't work in the first instance, not because of some of the technology, but it was difficult to degas the methane from some of the gas. But we actually got phase 2, so we're about to go again with that. Live and learn.
You absolutely do. If we stopped every time we came across a problem and went, "Oh, I can't make this work," then nothing would happen. We've got to be prepared to fail and learn from that and move forward. You've got to constantly be falling forward. I am going to force us to walk through all of those bits. So we've done heat, we've done ammonia. Now let's do phosphorus.
15 years ago, we did a test off of phosphorus recovery techniques at one of our sites at pretty decent scale. We had 6 different ways of removing phosphorus. And the reason for that at the time wasn't a circular economy thing. We had a load of P permits coming in at 0.5 milligrams per litre at the time that we hadn't got to. Those technologies were very good at taking out the phosphorus, and ultimately that ends in our biosolids, but also doesn't recover it in a beautiful form where we could then package it up for fertilizer. As a nation, we are now recovering a lot more of the phosphorus from our effluent than we used to have. We've probably taken 75% of the phosphorus out. It doesn't go out to sea anymore, which is great.
I'm a bit passionate about phosphorus on a separate topic, just because it's one of those things that I think it's an environmental crisis we don't talk enough about. There's a limit to the amount of phosphorus in the world. We all need it. All living things need phosphorus. But let's not go there. Let's keep plowing on with the topics. Fourth one, I think, was grit that you mentioned.
We have about 6,500 tons of grit that each year we send to a plant at a town called Coleshall down the road. We wash it and then it goes into a capping landfill. We've only got one site that does the washing, and it's with Suez actually. It's a really good bit of work they do.
Brilliant. Now I'm intrigued as to what you're going to do on circular economy for screenings, because what you can do really stretches the imagination.
We have about 17,000 tons of screenings a year, and the truth is that goes to landfill. So this is one that I say we haven't nailed by any means, but we've done a decent test on our test rig at Spurl with a pyrolysis process called Hero, which is good. And it works really well. It's a very small scale plant. You can either use it to produce a biochar because it's pyrolysis, or you can then keep going and effectively reduce the volume of material. So we're just finding ways to make the numbers work and scaling up.
There's a sort of plug and play, like a washing machine type pyrolysis unit, isn't it?
Exactly that, like a washing machine. It's a really good unit. And again, of course, the challenge will always be in the scale up, but it's good. I think what that reveals is it is possible to do something better with screenings than just simply landfill them. Currently landfill, what, £200 a ton, something like that. So whether you come in through the door of wanting to reuse it beneficially or in through the door of economics, there's a case that can be made, and we've never quite got it yet.
Thank you for being so concise on these calls. It's really intriguing to hear the breadth of Severn Trent's ambition and experience here. The last one I want you to touch on is obviously recovering the toilet paper.
So we get about 100,000 tons a year cellulose flushed down to us. And at Strongford, which is our Stoke-on-Trent site, we get about 5 tons of cellulose a day. And cellulose is really interesting, right? So we piloted it on the test place at Spurnell. We struggled with some of the things around it, things like permitting, because in that original vision we had for the biorefinery, all these markets are the things we were going to do with the products. To take a product to that market, you need end of way status. And to get end of way status is quite an onerous process. As our understanding emerges of things like PFAS, etc., it's right that we are careful about what it is that we're recycling. What we hadn't expected actually was the challenges to even be able to put it into our process to test. It takes it out of the normal process. And that's a permitting issue that we are working through with the Environment Agency. So innovation is like that, isn't it? You come in thinking that the problem is the technology. The problem is often not the technology.
I love the optimistic resilience that you've got there. We're going to keep playing on. We're going to keep trying this. And just for some of the audience, you might have got lost a little bit as to the cellulose. I called it toilet paper because that's the source of the cellulose. And what we're talking about is the toilet paper that people flush down that you're recovering when it gets into the biosolids.
No, before that, actually. So the Nine-House units, they're a set of two screens. The first screen goes effectively where primary settlement tanks would go in the process. So it's very early on in the normal process. The first screen takes out the sludge pretty much. The second screen takes out the very, very fine, thin fibers. And then you can either produce a pellet or you produce effectively a fluff. We are looking at a route actually into aviation fuels with that.
And does that starve your downstream digesters of organic matter and lower their gas production? Or does it mean that they are chomping on the stuff that is easily degradable and therefore you can have shorter retention times? Which of those two extremes does it go to?
More the second, because the cellulose is pretty hard and pretty inert to break down relatively. So actually, we're still pulling out the sludge on the first screen and then come back. In fact, one of the advantages of the process actually is it takes quite a lot of extra load off the downstream processes, which can give you more options. Actually, we got a digital twin at Strongford to actually think a bit about what is the right way to run this plant to minimize process emissions and maximize effluent quality and minimize costs. So all those things are actually improved because you take more load out.
Brilliant. Now, I know there'll be people listening to this saying, oh, but he hasn't talked about such and such. And we are constrained by time. And if you are someone listening to this and think that there is something that you would like to share around circular economy, the production of PHAs and biodegradable plastics or something like that, please contact us and we'd love to do a podcast with you. Now, Bob, we're running out of time. I did want to ask you about the net zero ambition and how that links to the circular economy. Just give me a little bit of, what are you doing on net zero?
So like many folks, we've got a net zero ambition of getting to net zero by 2030. We put quite a bold plan into our regulatory review. We've got about £300 million to invest in doing that. The majority of that is going into removing nitrous oxide, because nitrous oxide is the big ticket item for us. I mentioned Dactylayer before, so we've learned a lot from our Strongford trial. Because it's this catalytic converter, effectively it takes nitrous oxide, turns it into nitrogen and oxygen. But it's not cheap to roll it out everywhere or to all the big sites. Actually, you could deploy a much smaller area of this clever cover to remove a meaningful amount of nitrous oxide. So again, we've actually learned a lot about how nitrous oxide varies, both in terms of spatially down the plant and temporally in terms of with season and even time of the day. We're decarbonizing the fleet like most folks. We're doing some pretty cool stuff, like you may have heard of a process called LFAP, which sucks more methane out of the sludge before it goes to land. We've changed our process to have a different sequence into our anaerobic digestion. We've already got thermal hydrolysis, but we've just changed the process slightly.
There's a lot of stuff there to unpick, which we haven't got time for. And I'm going to come to our closing question. And it's always a bit cheeky. And I know you very well, Bob. We've known each other for a long time. So you get the really cheeky question. You get the question, when did you last cry and why?
I mean, it could have been the last one on the panel with you, Piers, but it wasn't. It was actually 2 nights ago. We went to a Sam Fender gig. I don't know if you know the performer Sam Fender, played in Newcastle, his hometown. So there's a bit of emotion in there when someone comes back to their hometown. They play in St James's Park, Newcastle, and he has a song called Remember My Name, which is effectively about his grandparents. And it's got a brass band in it. And I'm a bit of a sucker for the link between music and emotion and family. And I'm not ashamed to say I was in floods of tears just watching that.
Brilliant. I love it. You have been listening to the Exec Exchange with me, Piers Clark, and my guest today is Chief Engineer at Severn Trent, Bob Stear. And we have been talking about the circular economy, what works and what doesn't. I hope you can join us next time. Thank you.